Today, I'm super excited to share more about our work for the Explore SA Gawler Challenge presented by Team Strayos. The work is related to the application of deep learning CNN algorithms applied in the Gawler region and the prediction of the mineral deposits. This is our team of PhDs and machine learning experts ranging from mining, geology, and imagery data analysis. We're super excited to share more on this.
South Australia is rich in mineral resources and therefore is a prime location to develop a model to discover potential mineral deposits using the incredible amount of geophysical and geochemical data available. We leverage this by implementing a hybrid approach to mineral prospectivity mapping, where we use machine learning and deep learning techniques for pattern recognition of mineral deposits. By using a convolutional neural network, we can take a location with known mineralization and train it to recognize the patterns in the surrounding data. Using a neighborhood of information rather than a signature at a specific point allows for even better mineral prospectivity models. Our approach is outlined by 5 steps: feature selection, or determining the datasets used to train the model; data extraction and data preparation, where we select all the geophysical and geochemical features surrounding known and unknown mineralization targets; model development; and lastly, results, where we generate a heat map of potential mineralization locations. This hybrid approach using CNN leads to promising results that hone in on locations for further exploration. We demonstrate that this method overcomes challenges associated with mineral exploration and can be applied globally where data is available.
Our first step to build a CNN model is to select the predictor features that are the best proxies for ore formations. As the predictor features, we have selected 4 geophysical datasets shown in the figure, and also 92 geochemical evidence datasets shown in the table. The next step after selecting the predictor features is the data extraction from CERIG. We have extracted known mineral occurrence data from CERIG, imported that into QGIS, validated and processed, and then finally exported that as CSV. Our work is focused mainly on discovering copper, gold, iron, lead, and uranium deposit systems. The CNN requires both positive or mineral occurrences and negative or non-mineral occurrences datasets for training and validation. Mineral occurrences are the known mineral locations, whereas non-mineral occurrences are randomly sampled data using a couple different approaches. We found out that our first approach has a higher accuracy than the second approach, and will be discussed in results section.
The next step is to extract the training inputs. For the geophysical imagery data, we simply extract patches with size 6400 by 6400 square meters around the center of each point. For geochemical data, since it's sparse and non-continuous, here we train the KN model to select the 10 closest neighbors, and then calculate a weighted average using the inverse distance weights as the estimation of the geochemical data and target position. We developed a deep CNN classification model which takes both data as inputs. The raster patches will be fed into the CNN model to extract a no-dimensional feature vector. This image feature vector will then be used to concatenate with the geochemical data vector. And finally, a series of fully collected layers are used to make the final prediction.
We experimented with several configurations of the model, such as different techniques to sample the locations of non-mineral resources. And our 2 best models achieved the test accuracy of 83% and 75% respectively. We use our most accurate model to make mineralization predictions of the Gawler-Croton area. The model was further validated using CERIG resource data with 82% accuracy as shown in the table. The results are converted to a heat map of potential mineralization locations and classified as high, moderate, and low mineral target regions as shown in the figure. Conclusion. Our goal was to use the power of the deep learning CNN algorithm to predict potential mineral targets in the Gawler region of South Australia. We accomplished this by using CERIG to import the data, Quantum GS to validate and explore the data. Then we developed, trained, and tested the deep learning CNN model with 83% accuracy. In addition, the model was further validated using CERIG resource data with 82% accuracy. Finally, we believe that our results can be used as guideline to further reduce the exploration targets for copper, gold, iron, lead, and uranium deposits in Gawler craton area. Thank you.